this video we are gonna talk about the classification of hydrocarbons. So mainly we like to look up for the organic compounds, definition of organic compounds, hydrocarbons, saturated and unsaturated hydrocarbons, and the classification of hydrocarbons, and last we must discuss our quiz. So what are organic compounds? Let's talk about the definition of organic compounds. Organic compounds can be defined as compounds that contains covalent bonds between carbon to carbon and carbon to hydrogen atoms. Now let's see an example for organic compounds. C2H4 is known as ethene. So let's draw the structure of ethene. So we have double bond between carbon to carbon atoms and 4 hydrogen. So we can see the covalent bonds between carbon to carbon and carbon to hydrogen atom. So we can say ethene is an organic compound. Now let's discuss another example for organic compounds. Now let's see glucose. If we draw the structure of glucose, it's look like this. The molecular formula of glucose is C6H12O6. So in this structure you can see covalent bonds between carbon to carbon atoms and carbon to hydrogen atoms. So we can say that glucose is an organic compound because it contains covalent bonds between carbon to carbon atoms or carbon to hydrogen atoms. So organic compounds mainly consist of 3 elements: carbon, hydrogen and oxygen. It can be carbon, hydrogen and oxygen together, or it can be carbon and hydrogen only. Now let's talk about hydrocarbons. So what are hydrocarbons? The hydrocarbons can be known as organic compounds that contains only carbon and hydrogen. Hydrocarbon doesn't contain oxygen. For example, let's see methane. So this is the structure of methane, and another example is ethane. So you can see methane and ethane only contains carbon and hydrogen. So is glucose is a hydrocarbon? No, glucose is not a hydrocarbon because glucose contains oxygen. So let's talk about saturated and unsaturated hydrocarbons. So what are saturated hydrocarbons? Saturated hydrocarbons only contain single bonds between carbon atoms. So in saturated carbons we can only see single bonds between carbon atoms. Okay, now let's see example for saturated hydrocarbons: alkanes and cycloalkanes. Now let's see example for alkane. So this is butane. So you can see the structure of butane only contains single bonds between carbon atoms. So this is cyclobutane. In this structure also you can see single bonds between carbon atom. So butane and cyclobutane are saturated hydrocarbons. So let's now test your understandings about hydrocarbons and saturated hydrocarbons. So state this true or false. All cyclic hydrocarbons are unsaturated. Is this true or is this false? The answer is false. We know cycloalkanes are saturated. So cycloalkane is a hydrocarbon. So this statement is false. So now let's talk about unsaturated hydrocarbons. So what are unsaturated hydrocarbons? Unsaturated hydrocarbons contains double bonds or triple bonds or both double and triple bonds between carbon atoms. So let's write an example for hydrocarbons. Butane. Butane is a unsaturated hydrocarbons. So you can see in this structure, butane contains a double bond between carbon atoms. So you can say butane is a unsaturated hydrocarbon. So now let's talk about the classification of hydrocarbons. So hydrocarbons mainly divide into two parts. The first part is aliphatic hydrocarbons and second part is aromatic hydrocarbon. So what is the main difference between these aliphatic and aromatic hydrocarbon? The main difference is in aromatic hydrocarbons contains benzene. So what is benzene? Benzene is a ring shaped molecule. The molecular formula of benzene is C6H6 and this is how you draw a benzene molecule. Okay, now let's look at some example of aromatic hydrocarbons. So the first one is nitrobenzene. It contains a benzene ring and it's a aromatic hydrocarbon, and second molecule is also containing a benzene ring and it's also a aromatic hydrocarbon. So you can see first molecule and second molecule are aromatic hydrocarbons, but in third molecule they don't have a benzene ring. It's not a benzene ring, it's a cyclohexane molecule, so it's not a aromatic hydrocarbon. I think now you understand how to identify aromatic hydrocarbons. So now let's talk about aliphatic hydrocarbons. Aliphatic hydrocarbons can mainly be divided into three groups: alkane, alkene and alkyne. Aliphatic hydrocarbons can be a linear molecule or it can be a cyclic molecule. For example, pentane is a linear molecule and cyclohexane is a cyclic compound, but pentane and cyclohexane both are aliphatic compounds. That means aliphatic compounds can be linear and also can be cyclic. Now let's talk about alkanes. So what are alkanes? Alkanes are hydrocarbons that contains only single bonds between carbon atoms. We use "ane" suffix for naming alkanes. For example, propane, we use "ane" in the end, and methane, you can see we used "ane" suffix at the end. If a molecule has a "ane" suffix at the end, we know that is a alkane. And general formula of alkane is CnH2n plus 2, where n is the number of carbon atoms in alkane molecule. So this general formula is valid for only linear alkane molecules, not valid for cyclic alkane molecules. So this is an important formula that you must remember. Okay, now let's test your understanding. The general formula of cycloalkane is CnH2n plus 2. Is this statement is true or false? You know the statement is false because it's only valid with linear alkane molecules. So let's see an example for alkane, propane. You can see the "ane" suffix at the end. So in this molecule you can see there are only single bonds between carbon atoms. So it's a alkane. Now move on to alkenes. Alkenes contain double bonds between carbon atoms in the molecule. It can be a single double bond or it can be more than one double bond between carbon atoms. The suffix is "ene". For example, propane suffix is "ene". Butane, the suffix is "ene", "ene". That's how you identify a alkene. Alkene has a double bond or double bonds. The general formula of alkene is CnH2n. But you must remember this important thing. This formula is only valid if there is only one double bond between carbon atoms. Okay, now let's look at examples for alkene. Butane. Butane contains 4 carbon atoms, and you can see there is a double bond between second and third carbon atom. So butane is a alkene. So state this statement true or false. If an alkene has 2 double bonds, the general formula is equals to CnH2n. Is this true or false? You know the answer is false. Only there is one double bond, then the general formula can be equals to CnH2n. Now let's talk about alkyne. So what are alkyne? Alkyne contains triple bond or triple bonds between carbon atoms. Or alkyne can contain triple bonds with double bonds. The suffix of alkyne is "yne". The general formula for alkyne is CnH2n minus 2. So this general formula is only valid if there is only a single triple bond in alkyne, not valid for every movement. If both double and triple bonds there is in a molecule, but we identify that molecule as a alkyne, not alkene. If there is a triple bond and double bond, we identify that molecule as a alkyne. Now let's see example for alkyne. Butane. So butane contains 4 carbon atoms. So you can see there is a triple bond between second and third carbon atom. So you can say butane is a alkyne. Okay, so that's the end of our theory session. You can screenshot these notes if they are important to you, or you can use this as short note. So now let's move on to our quiz. So now let's discuss the quiz. The first question is, which of the following hydrocarbons belongs to alkane group? We know the suffix must be end with N. The answer is B. It's methane, because it's ending with suffix N. Okay, now let's move on to the next question. Which functional group characterize the alkenes? We know alkenes contains double bonds between carbon atoms. So next question, what is the general formula of alkanes? We know the general formula for alkanes is CnH2n plus 2. Sorry, I made a mistake there. The answer is ACnH2n plus 2. Okay, let's move on to the next question. Which hydrocarbon has a triple bond between 2 carbon atoms? We know it's alkyne. The next question, which of the following is a saturated hydrocarbon? We know saturated hydrocarbons are only alkanes and cycloalkanes. So the answer is ethane, because ethane is a alkane. The next question, which hydrocarbon has a ring structure? Alkane, alkene, alkyne, aromatic. We know aromatic carbons definitely contain benzene. Benzene is a ring structure. So the answer is D. The next question, what is the hybridization of carbon atoms in alkenes? So let's draw a alkene. So you can see in this carbon atom there are 3 sigma bonds. If there are 3 sigma bonds, the hybridization is sp2. The answer is B. Okay, the next question. Which of the following is true regarding to cycloalkanes? The answer is D. Cycloalkanes only contain single bonds. We know if it's an alkane, it's only contain single bonds between its carbon atoms. Which of the following is an example for aromatic hydrocarbon? Aromatic hydrocarbon example is benzene. The answer is C. Which of the following hydrocarbon is classified as non-aromatic cyclic compound? This compound has to be cyclic and non-aromatic. The answer is cyclohexane. It's cyclic, but it is not aromatic because cyclohexane don't have benzene. So next question, what is the hybridization state of carbon atoms in benzene ring? So let's draw a benzene molecule. So you can see there are double bonds between benzene carbon atoms. So if there is a double bond, it contains 3 sigma bonds, and if there is 3 sigma bonds, it shows the sp2 hybridization. So let's move on to the next question. What is the term for a hydrocarbon molecule containing both double and triple bonds? As we learned earlier, if there is a triple bond and a double bond, we specify that molecule as a alkyne. So answer must be a alkyne. It's anion. It ends with YNE suffix. So that's the end of our question discussion. Please subscribe to my YouTube channel if you find this content valuable, and leave a comment what you want to study in our, what topics that you want to study in our YouTube channel, and share this channel with your friends. So study hard, study smart, and have a great day to you all. Bye.